Hey everybody, it's Matt from Eastwood Company. We're here in the Eastwood garage, again doing a live technical demo. You can watch this on Facebook, on our YouTube channel, and you can also watch this right on our homepage. For anybody who hasn't watched one of these before, we try and make this as interactive as possible. So we want you guys to log in and chat. We got Randy sitting over here that you've seen a lot of our videos.
Yeah, and don't forget, next Tuesday we have a live video on powder coating. You can see one of the samples I was powder coating this morning, actually, showing what our atomic orange looks like over white and just over chrome. And we're going to be doing a lot of other stuff, spraying out some chrome powder. So that's Tuesday at 3 o'clock next week.
So yeah, make sure you tune in, set your calendars for that. But Randy's going to be on the chat there, answering any questions you may have. He's also going to save some questions for me. I'm going to answer them live on camera for you. And if there's anything you want to see demonstrated, if I got everything set up, I'm happy to do it for you guys. So the topic today that we're covering is basics to MIG welding. A lot of people that buy our MIG welders, we've found, are guys that are just doing it at home, or gals that are doing it at home that maybe are beginners, just starting out, what I would call a novice. And there's a lot of stuff you can learn over the years to help you be a better welder. And a lot of it's just settings and technique and things like that. So I'm going to go over a little bit of this. But also, again, want it to be interactive. So if you have any questions about problems you're having with MIG welding or techniques, drop them in the comments there, and we will do our best to answer them for you and hopefully help you guys out. So for anybody that's just starting out with MIG welding, just starting to learn, this is our Eastwood MIG 175. The controls on it are about as basic as it comes. We have a arc voltage here and a wire speed. The voltage is basically your heat, so that's going to tell you by turning the knob, it's going to get you the different temperatures. And then the wire speed is going to, just like it sounds like, how fast the wire comes out of the machine. The perfect weld, one of the factors is blending these two knobs to get a nice setting for what you're welding. So a good thing about our welder in particular is it has infinite adjustability. So it doesn't have preset or individual clicks for each of these. You can set them wherever you want. You can blend the two of them together. Now our machine does have some kind of dummy settings that I like to call them, where if you get too far out of whack with your welder, it will basically after a split second will go to like the closest to that setting it can get. So for instance, if you have this machine set all the way down to like B or A, and you got it cranked all the way up to a 10 wire speed, it's not going to let you do that. It's going to kind of go back to a closer setting to you after a few seconds. What also could happen is, probably more common that I see, is people have it set really hot and then they try and turn the wire speed way down to try and, I guess, burn it in better. But what happens is you'll start burning the wire back into the tip, or the machine will kind of reset itself back closer to maybe 5 or 6. So just keep that in mind if you're ever welding with one of our welders. If you get too out of whack with your settings, it's going to kind of jump to an auto set internally in the machine. So again, this is the settings on-off switch, which is obvious. We have the welding gun or torch here. And like a lot of people call this, it's a squirt gun. You hit the trigger, puts out the wire, it creates a weld. So it's pretty simple as far as making sparks go, but there's a lot of technique involved in getting a good clean weld and learning how to set your machine up. So inside of the machine, how it works. So we got our ground cable on the table here. We have our gun that we showed you, our torch. Then inside here we have our spool of wire. This is our filler wire. So this is what's actually coming out and you're melting into the metal. We have a drive roller in here, and drive roller has a little motor inside that spins and pulls the wire through. The most common wire sizes that are used in automotive use at least is 023, 030, and sometimes 035. But generally for 90% of automotive use, 023 or 030 is kind of what I like to use. So this machine will accept any of those sizes. This little drive roller down here actually has 2 little grooves in it where you can unthread the knob and you can flip it over. You can flip-flop it. So right now we're running 023, and I have it on the smaller groove side, so I had to take this knob off, pull off my roller, and flip it over and slide it on. And it's as easy as that to switch it over. So real, you got your ground cable in here and your power. These two here, if you're welding Flux-Core, you may have to change the polarity of the bottle and use solid core wire like we have here. So solid core, it does not have a coating on it, the Flux-Core, much like a stick welder, or the electrode on a stick welder is going to have a coating on it that burns off and actually creates the gas that shields the weld. With using a solid core wire, you're going to have gas here that actually comes out and kind of puffs around your weld and gives you a little bubble so that it keeps the weld pure. So you need some sort of shielding gas, whether it's burn off when you're welding or whether it's coming out of a bottle. So as on the bottle here, and I don't know, it's probably kind of covered, but any of your bottles, if you guys are unsure, they're always labeled right from your welding supplier, your gas supplier. They're always labeled with what they are. So on this, and you also see a little kind of green symbol there, but what you want to look for is on the bottom here, it's going to tell you the mix of the bottle. So generally when you're welding with a MIG welder, if you're doing any kind of ferrous metal, you're going to be using a mix. And the bottle, like for instance, we like to use 75-25. You can use 80-20, but it's going to tell you right on here what that mix is. But those two are the most common. So that's argon and CO2. So CO2 is going to be the 25%, the argon is going to be the 75%. And the two of those, they work together to give you the penetration you need and also to keep the weld clean. Once you start getting a little far out of whack, or if you use, if you use straight argon, you're not going to get the penetration that you need. So you need that little bit of CO2 in it when you're welding with a MIG welder to get the weld that you need, and it's clean and gets the penetration that you need. So if you're welding with our machine and some other machines, you can hook a spool gun up, where you can put a spool of aluminum wire in there and actually MIG weld with aluminum. With that, you do need to switch the bottle and run to 100% argon. That's the only instance on a MIG welder where you're really going to be using argon and for automotive or general use. So today we're just doing steel. So we're just doing the basics here. So I just have our CO2 bottle, it's 75-25. And that should get us going pretty good. So I'll get this flipped back. And do you have any questions yet for MIG welding before I jump into?
No, but Yannick, who's on here every week, wants to know when the Contour SCT is coming out.
So Yannick is a good follower of ours that watches everyone. I do appreciate that for you watching all of our lives. It's great to see we have some return viewers. Wants to know when the Contour SCT is coming out. I don't know if we have one hiding here, but anyways, we have a really cool surfacing tool that's coming out, and it should be coming out real soon. You might see it within the next week or two, possibly. It should be coming out for sale on our website. If you guys aren't familiar with this tool, it's the first time you've ever heard of it. It's getting a lot of buzz. If you check our Instagram, Eastwood Co. is our username, or you check on our Facebook page, we have a couple little teaser videos. But it's pretty much going to change your whole entire outlook on stripping paint or resurfacing metal. It's going to cut the time down and make your life a lot easier. We're really excited, and I've been really happy that I've had one of these tools to use and play with. So make sure you keep an eye out for that. But yes, very, very soon that will be out. Make sure you follow our social media because it's going to sell out pretty quick, I imagine. Anyways, good question. So we're going to move into actually welding here. And I'm going to show you guys some of the basics for holding your hand, how you hold your hands when you're welding, and technique. So of course you want some good gloves. You don't want to wear like knit gloves, or even if you're wearing like mechanics gloves, traditional mechanics gloves. They don't have the protection on the back. It's just kind of like a neoprene or a mesh. The sparks from MIG welding are going to go right through that and burn your hands. So a set of gloves, nice leather gloves to have a cuff on them, are really good. I do not suggest, if you can afford it, to use your big, heavy, what I call astronaut gloves, your stick welding gloves. They're the real thick, heavy ones that are used for stick welding. They're not as good for MIG welding unless you're doing some kind of real heavy welding for real long periods of time. Otherwise, you don't need those. What I found is that they are kind of cumbersome, and it's hard to maneuver with those big, heavy gloves. And getting something a little thinner, like these Tillmans that we offer, they're still a nice heavy leather, but they're not so heavy with all the insulation that you feel like you're an astronaut when you're using them. So, good set of gloves, welding jacket, which I'm already wearing to weld in, and yeah, that's your basics, other than a helmet, of course. We'll get into that. So our bottle here, I'm going to turn so hopefully Joe can get this. So our welder here has 2 gauges on it. So you have our tank pressure on this side. So this tank's pretty much a brand new tank that's already that's full. And then we have our other gauge over here, which is actually our flow when you hit the trigger. And I'll show you guys here. So what you're looking for on this gauge is you want to look to where it's at when you hit the trigger, not necessarily where it's at when it's sitting at rest. It's where you want it when you hit the trigger. So when we hit this trigger, it drops down real quick. So it's sitting up at 20 here, and again, you want to read, I skipped over it, but you want to read on this particular gauge, you want to read the inside, the CFH, the red numbers in here. You want to read those. So if you look at any of our instructions where it tells you how to set the machine up, the number you're looking for is the CFH. We've oftentimes had customers that have had problems where they're saying they're using excessive gas, they're blowing through a bottle of gas, and they think that there's a hole or something in it, when really what it is they're reading the black numbers on the outside. So if we tell them that it needs to be 10 to 15 CFH, but they're reading the outside, you can see, and that's what it's flowing when you're hitting the trigger. 15's way up here, which is actually 30. It's about double what you need. So you're using twice as much gas as you need. You don't want that. And you can hear it right away when you hit the trigger. Now, let me turn it up a bunch. We're going to waste some gas. Oh, I'll try and hold it up here so you guys can hear it. And we'll see if you guys can tell the difference. So I'm going to turn it back down. And we're still too high. It's getting quieter. That's about where we want to be. So that's a lot quieter. It's a distinct sound. You'll hear when you do this a little bit. You can stay right there, Joe. I'll come back. So cut that extra wire off. So again, when we hit this trigger, we want it to drop down. And just keep playing with the knob to get it about where you want it. So we're about at 15 there when I'm actually on the trigger, which is good. So that's where we want it to be. So make sure you're doing that. And make sure that your bottle's all the way open. If you have it just barely cracked, it may not be letting the correct flow through. But the biggest problem I've seen is customers or beginners read these gauges wrong, and then they're either wasting gas or they don't have enough gas. If you have not seen the video, we did a live video probably a month ago or something like that, where we did diagnosing bad welds. And I spent pretty much the whole broadcast just showing you what each type of bad weld is caused by. And if you haven't seen that, check either on our YouTube channel or you can scroll down in our Facebook videos. You can see that video where I go into detail actually diagnosing bad welds. I'm not going to get as much into that today because we're really just going to show technique and laying a nice weld on both sheet metal and thicker gauge stuff. But make sure you check that video if you haven't seen it before. All right. While I'm getting set up here, any other? Okay, cool. So, got my dials all messed up here. So I'm welding with 023 wire today again. And I'm going to set the machine up where I like it to be for welding sheet metal. I like to weld, if possible, if it's nice, good, clean sheet metal. I like to weld a little hotter than the inside the machine. In our machine in here, which you can't see right this second, but we have a little chart that gives you a baseline settings for getting yourself close when you're welding, but it's not exactly where you want to be all the time for every instance. So use that to get yourself close, but I would suggest getting a piece of sheet metal that's the same thickness or close, very, very close to it, or very close to what exactly you're welding, and set up your machine doing that. Get your baseline setting and start welding and getting it close. And as you play with your dials, you get it really perfected, and then you're set. So for welding sheet metal, a couple things I wanted to go over for welding sheet metal with MIG that is an issue that beginners have. You don't want, if at all possible, the best possible situation for welding sheet metal is to butt it together. If you're doing like a patch panel or something, is to butt it together and have basically no gap when you're welding. So you're melting the two of those pieces of metal together, and your filler metal is melting, most of the way through, if not all the way through, giving you a nice clean weld that's fused all the way through. That can be difficult to do, especially if you have to grind the surface. What will happen is when you start grinding the surface, you're taking away the weld, and you end up with paper thin weld that isn't going to really hold very much, especially if it's something like a rear quarter panel or something. It may see some vibration and may see some heat from the sun and everything else. That's not always good. So a cool tool that we came up with to kind of solve that issue of having to grind off a lot of your weld. So you have these cool little pliers here called the Perfect Panel Prep Tool. Whew, I knew I was going to mess that up. So Perfect Panel Prep Tool has these cool little jaws here that are shaped in such a manner, oh boy, that it puts a little bevel on your panel. So what you can do is you can put the same bevel on the panel every single time. And with these pliers, you can quickly go over a patch panel on both pieces, and you can put a little bevel in each piece, which gives you a little valley to leave your welds in, and requires almost no grinding at all if you get your machine set up right. So I have two that we did for a sample that aren't tacked together here. So if you can see, I'm just going to try and get a better shot to see the edge of these. So it puts a little tiny bevel on it, not a lot, but just a little rolled edge that leaves an area that you can lay your weld into. And then when we put this together here, like so. Just trying to get this so you guys can see. I'm going to try and hold these. You can see it leaves a little valley that we can weld in, which is pretty cool. Now I have one here that I got set up that we're going to actually do some welds on that you can see. That's pretty cool. It's got the little bevel in there, and when we're dropping our weld in there, just that little tiny bevel allows you to put the filler material goes in there, fills up that bevel, and leaves it almost completely flush on the top. The back side has just a little V in it, which isn't an issue, especially if it's a hidden panel. But it's much, much better than overlapping panels, which is not optimal to do, is to overlap panels if you're doing something like a patch panel. It's not the best situation. So with this, you're doing a nice clean butt weld. You're not putting a big gap in there that you're trying to fill with filler material and blowing holes, and going around in circles. Kind of a pain. To do the bevel, just put it into the stop there. Let's loosen this just a hair here. There we go. And close it. Move the width of your jaws there. Put it in again. And you just go along just like that. Now if you got strong hands, you can probably get it so it doesn't lock and you make the bevel, but I'm trying not to drop this piece here, so I'm going to let it lock. But that's all you do. You just go along the panel. It's got kind of a stop in the back, so you keep it basically the same the whole way along. Pretty quick. I mean, as quick as any other method. There we go. So I just did that quick little bevel there. This piece wasn't cut perfectly straight. That's what that little nub there is. But yeah, real quick, we put that little bevel in it. Awesome for welding sheet metal with a MIG welder. It's probably the best thing that's ever come out for MIG welding on sheet metal as far as an accessory for panel prep goes. This guy's awesome. So I'm going to show you guys doing a little bit of spot weld, stitch welding with sheet metal. And I got the machine set up here. And just to double check, because I know where I like this. But for what we're welding here with 20 gauge, our machine calls for E5 is what it's calling for here with this wire that we're using. You can see I got it set up quite a bit hotter here, and the wire speed's higher, quicker. But that's just what I like for laying these welds. I've gotten pretty good over the years of getting in and getting out when you're doing these stitch welds. You'll probably find that setting is a little, I guess you could say, on the safe side. So you're not going to burn through as easy. So the way I have the machine set up, it's a little easier to burn through because you got to be real quick, identify the spot weld or stitch weld, and as soon as you see it flow out, you got to let off. If you're a little slow about it, that's going to cause an issue. And you might burn through with the setting I have. But I found it lays really nice flat welds on sheet metal. So we got our piece here that's beveled with the Perfect Panel Prep tool. And I'm not going to weld quite yet, but what I like to do, the way I've done it that makes it easy for me to set up is, and this is especially good if you're somebody that doesn't have great eyes, you can set your torch down, the nozzle on the edge of the piece, and you can get yourself lined up, and then you can tilt it up where you want it and put your helmet down and hit a weld. So I got to tilt it up where I want it. I know I'm close even if the lighting's not great, and I'm going to hit my trigger and let off. I can hear how short of a period of time I'm on that trigger. And as soon as I see that it's starting to flow out, I let off. So I'll do a few more in here. If you have any questions about MIG welding? It's come up yet?
Yes, actually, Cyril Carlin, who's on here for about all of our live videos, would like to know if you can weld stainless with a MIG welder. Okay,
so we had a question about welding stainless. Can you weld stainless with a MIG welder? And the answer is yes. You can weld stainless with a MIG welder. It isn't as clean, obviously, as TIG welding, but you can weld it together. You're going to be using basically the same exact setup that we're using here. You can weld stainless. Now, if you're using just your standard wire, one thing to keep in mind, using your standard wire like we're using here, the weld will rust. Keep that in mind. If you're welding stainless, like say you're doing an exhaust system, probably one of the most common things that I see people trying to do with a MIG welder on automotive is welding like a stainless steel exhaust. You got to keep in mind that seam where you're welding is not stainless. So it's going to rust over time, so you do need to protect that weld. But yes, you can meld it together, you can weld it. You can weld just a standard mild steel to stainless steel with a MIG welder, no problem at all. Use the same wire, it's not an issue. If you're getting into a little more in depth, then if you're going to be doing a lot of stainless welding, you may want to start thinking about learning how to TIG weld. It's a little bit cleaner of a weld, and you can fuse it together and get a little bit cleaner of a setup if you're doing something that's more than just piecing together an exhaust system or repairing something. So that was a good question. If you guys have any other ones, feel free to shoot them over. So the stick out my wire here that I have, you can see is not very much. Something I see with beginners that they often have trouble with, especially I've found guys that have sight that maybe isn't as good as it used to be. They tend to run their wire, well, that's probably a little extreme, but I've seen commonly where leave the wire hang way out like that. What you're doing is you're actually dropping that voltage, the power that's actually being put into the panel, because it has to travel all the way through there rather than right where it's touching. It's also going to keep you further away from the panel, and you're going to lose some shielding gas. So you may get a weld that's porous, that's not a good weld. So by keeping it far away like that, that is going to cause an issue. You're going to find that your welds are also going to suffer from that. So let me do one with it held further away. Listen for the sound, and then I'll do one immediately after that's with it closer, and you can listen to the sound, and then we'll show you the two welds next to each other. So same settings, just my hands at a different position. And then cut a wire off. You hear the sound a lot different, and need it up higher like that. So you can see this one. You know what? Let me turn it sideways so you can probably see it a little better. This first one here is where it was further away. You can see how it's up over the panel. It's up higher, and this other one's pretty much flush there. So we're going to have to do a lot more grinding. All I did was just had the wire further away and my hand a little further away, and made that big of a difference. That could be, and that weld's not going to be as burned through as nicely, and you're going to have to do a lot more grinding, which puts more heat into the panel, which causes more warping. It's just all around bad. So that's two things to show there. Now, jumping around is another thing I wanted to cover for sheet metal. People are always talking about all these different methods for keeping the metal from warping when you're MIG welding sheet metal, using an air nozzle, using water, everything you can think of. You know, only doing one spot weld and walking away for 20 minutes and coming back with the panel cool. It doesn't matter what you do, what magic, black magic that you think happens. Metal warps anytime you put heat into it. Sheet metal is going to warp no matter what. To some degree, it's going to warp when you're doing a butt weld like this on sheet metal. By doing this perfect panel prep tool, it puts a little bevel on both sides of the panel, which actually puts some strength into these two pieces, which will resist warping a little bit. So it's actually pretty cool. For this, it's going to help the panel from warping, but it's still going to create some warping. So it doesn't matter if you weld 3 of these together 3 times in a row and then jump over here and weld 3 times in a row, or if you do 1, it doesn't matter, it's still going to warp. But what changes it is how much heat you put into the panel. So if we welded this all in one shot with a MIG welder, it's going to get all hot and crazy and warped. And the downside is you can't really hammer and dolly a weld with a MIG weld as much as you can with a TIG or oxyacetylene weld. So you can't really reverse it. You're kind of stuck with that warpage to a degree, which is pretty difficult. So, but using this tool, it gives you a little strength in the panel, and by making sure the panel is at least cool to the touch in the area that you're welding before you continue to weld, that's really the only rule of thumbs I have. I have sometimes used compressed air. I don't like to use water. Shocks the panel, work hardens by doing that, by putting water directly on a hot MIG weld. I don't really like doing that, but using some air lightly does help a little bit, but you should wait till you can at least touch it with like with your hand a little bit, that it's nice and cool or warm before you start welding. So I'll do a little bit of jumping around here. So at this point, you can already see getting a little warpage going on there. Now this is going to be a little more dramatic because nothing's holding this piece together. There's nothing on either side of it to kind of keep it in place. So it's going to warp a little bit, but the Perfect Panel prep tool, pretty kick-ass. So that gave us our nice flat welds here, so you can see.
What size wire are you using for that sheet metal? Or what size wire would you use, in case you're generic there?
So we had a question about what size wire to use. As mentioned, when I had that door open, I'm using 023 wire. So I got the little roller wheel flipped over. So 023 is the best for sheet metal. If you're doing 18 gauge, well, really anything, 16 through 20, which is probably the most common sheet metal that you're going to use in automotive use. 023 wire is probably the best. 030 you can get by with, you just have to change your settings dramatically. Anything thicker than 030 I wouldn't suggest. What you're trying to do is match when you're doing sheet metal, you're trying to match the filler material or the wire as close as you can to the thickness of what you're welding. So if you put 035 wire in there, that's another reason I don't really like Flux-Core, is Flux-Core 035 is about the thinnest you can get. 035 is thicker than the material that you're welding, so you have to turn the welder up actually hotter. Basically, you have to turn the welder up hotter than required to melt the metal, the base metal, to melt the actual welding wire. So it creates more warpage, starts blowing holes in panel. It's not as nice. So 023 wire is pretty darn close to 20 gauge, which is what we're welding here. So it doesn't require a lot more heat to melt it into the panel. So that's what I prefer to use. It's really nice, flows really well. So that's a good question though. Any other? Okay, cool. So showed you the jumping around, doing the stitch welds on a panel. We jump around, keep going back and forth. We got the whole thing filled here. Nice solid weld. If we were doing something like a patch panel, quarter panel or something, where it needs to be fully welded, and then you grind it all off, make it smooth, and then from there you can do your primer, filler primer, however you prefer to do it in whichever order, and work your way up from there. So, welding nice MIG welds on thicker metal, running a puddle. Everybody wants to do a really nice looking weld, especially when you're doing, and a strong weld, of course, most importantly. So I'm going to turn the welder up. I'm actually, and this is again where it comes into the technique. So I was on H, like 6.5, I think it was. I'm only bumping it up one setting here. I'm going to go to 7. I'm welding substantially thicker metal here. I believe this is 1/8 inch that we're welding here. So I'm welding an 1/8 inch plate here, cold rolled. And I only turn the setting up just one little click, but it's all in the technique, how quick we're going to move across the panel and how we hold the torch and everything. So when you're welding, laying a puddle, I like to, let me draw, let's draw here, 1 second. I'll do it on this piece here. So when we're welding along, there's a couple different ways. You see people moving the torch or the gun to put their weld in. What you're doing is you're kind of backstepping to make sure that that weld is coming back into itself. You're getting full penetration and filling the full entire gap. So there's a couple ways you can do it with your torch. You can do little loop-de-loos like that. with your torch. Where you can do, what I kind of do is letter C's, or what I would say is C's, but you can also call them shark teeth. Little letter C's like that, back and forth. Either way, what you're doing is you're coming forward and you're coming back into the weld with your puddle, and you're overlapping. Any of these methods are okay. You can even go back and forth like this if you want. Boom, 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 like that. If you're trying to fill up a bigger area, you can do something like that. But you want to try and come back into your weld a little bit in some methods. So to show you on the metal here, when I'm welding, you'll see me kind of doing a little motion like this. All right, and back. And that's my little shark teeth or my little C's. I'm kind of going back and forth like that, moving the puddle around, back and forth over top of itself. If you're doing the loops, you're just doing little circles like this. Looks basically the same. You're just going in a circular motion like that. Whatever is good for you, whatever works, try all those methods as long as you're getting a nice overlapping weld without having gaps in between. So you're going to get those nice looking welds. So that's your movement, if you will. Cut this off a little bit. Now, for getting yourself set up for as far as being comfortable and getting a good hand position, what I like to do, and when I teach a lot, when we do a welding class here where we teach beginners with the hands on, what I like to do is you have them set your arm down on the table. I'm left-handed, so I hold the torch, the gun in my left hand, and I use my right hand as basically just the balance point. What I like to do is I put the torch and I lean this little curved section on my hand. What that allows me to do, I'm trying, so you guys can see, that gives me, so I can do this motion, I can move around, I can turn it. It gives me a lot of maneuverability, I can maneuver around really easily. Now if we were just holding the torch like this, trying to weld, like I've seen some guys do, or beginners do rather, what's happening is you're just fighting gravity and you're trying to, it's impossible. You're not going to make a nice weld. Well, I should say impossible. Nothing's impossible, but it's very, very difficult, especially for a beginner, to get a good weld just using one hand. So you can use your side of your hand like this. You can use a finger. Like I said, I like to rest it kind of here, top of my hand or top of my finger. Use that for an axis point, to kind of turn and weld with. So whatever the name of the game is getting comfortable. You want to get yourself nice and comfortable, get yourself rested if you can. I know there's times where you're welding underneath the car or overhead where you can't get comfortable, but it's still good even if we're welding up overhead or something like that. You can put your arm on whatever you're welding and you can still do the same thing. Get my hand like this and I could weld overhead or straight up and down, vertical. So whatever it is, try and get comfortable. So that's just the ways that I like to hold the torch and weld, but you can practice with however you prefer. So I'm going to do, first of all, I'm going to do a little run just on the flat here. So I'm going to do some longer passes here. Towards the end here, we're going to finish up. I'm going to do some longer passes so you can really see the weld. But I'm going to do one here just in the flat, just to exaggerate the movement of my hand so you guys can see how my hand is. And just keep an eye on how I'm moving the torch. And you can see. So I was trying to really over-exaggerate that spinning to show you guys, or the loops to really show you what it's like when you're moving your hands, so you guys can see. Before we put it under the helmet here, let you guys just see that. So now I'm going to do a couple under the helmet. We're going to throw a cool lens on so you guys can see what it looks like under the helmet and do some welds. Do you have any other questions? Okay, cool. All right. So, put this out of the way. You all ready, Joe? Yep. All right, cool. So I'm going to do, and let me just get this. I'm going to cut the little ball off the end of the wire. If there's anything you care about. So you get, right from the beginning, you're getting a nice clean weld. So I'm just going to make sure I can do this whole pass without having to move too much. So I'm not going to exaggerate them as much this time and just focus on moving the puddle. Nope. You could hear, at least I could hear them, a couple little slip-ups. What was happening is I had too much weight leaned over here because I was trying to keep my head back. But still, not too bad. A couple little I could hear, but I'm going to do one more here, and then we'll take the lens off, and then we'll show you the actual weld so you can kind of see, and I'll point out a couple things. I'll let you see one more here. Keep an eye on how we're moving the puddle around as we're going. Let me see if I can get this. I'm not leaning as hard on my arm. Good. So I'm moving the torch, I'm going from the top to the bottom as I'm doing my circles. Focusing on moving that puddle. And you kind of want to keep that sound the same. When you hear it spit a little bit, might mean that I jumped a little differently or I spun my hand a little differently. Come around the corner here, lid off. So this guy's pretty hot, but you can see the two that I did here. Joe's going to get in pretty close here. But they look fairly the same, with a couple little spots where it was spitting. Well, I could hear it spitting. It may be hard to distinguish. I'm going to use some wire as my little pointer here. Some of these spots, like right in this little spot here, that's where it might have made some sound. And all that was is my hand was just turned a little down instead of up. But you want to keep that sound kind of the same. That you want a rhythmic sound, and that's you doing those little swirls or C's or loops. So you're trying to keep in there. You want to keep when you look down the weld, you want it to be a nice, I don't see anything that's protruding out from it. And I'll turn that, so if you want to, let me know when you're ready, Joe, I'll turn that. So I'll turn this so you guys can see. When you look down a joint like this that you're welding, this is pretty hot, so let me see if I can. So if you look down that joint there, you don't want any area to be bubbled up or higher than the rest of it. You want it to be a nice flat weld in that corner of that joint. Now, if we wanted to do something where this was going to be under a lot of stress, or something that's we really want to weld it really strong, even more so than just doing this, we could bevel this area we just welded, lay that first weld there, and then we could come back and weld over top of it and fill in even more to get an even stronger weld. But I was mainly showing you the technique today, so hopefully that gave you an idea under the lens, under the helmet, so you could see what it's like pushing a MIG weld along. Any other questions? If not, we're gonna call it quits for the day.
That's it.
Cool. So,
Oh, don't forget Tuesday, our powder coating demo.
Yeah, so Tuesday we have a powder coating demo. So if you guys want to learn about powder coating, we're going to be giving you a full demo. Randy's going to be heading that up, showing you guys powder coating, and you guys can learn about different techniques for powder coating, which is going to be really great. So make sure you tune in Tuesday, 3 o'clock, same time as we started today, and you guys can watch that. So thanks everybody for watching. Hopefully you learned something. Make sure you share this post so all your friends know and everybody continue to watch this and interact. So thanks for watching. I'll catch you guys later.